We are going to talk about end-to-end CI/CD observability with OpenTelemetry. I am Ekansh. I am a software engineer with SigNoz. SigNoz is an open source observability platform. And this is Shivai.
Yeah, hi everyone, I'm Shivai with GitLab.
Yeah, he is a DevX at GitLab. Yeah. So let's do a recap of what we are going to talk about. We are going to talk about ArgoCD. So ArgoCD is a microservice which helps us automate deployments. We are going to require the DORA metrics from ArgoCD to assess the deployment information of all the microservices and the queue depth of it. Apart from that, we are going to talk about Argo Workflows. So Argo Workflows is a container native workflow engine. And we are going to extract the DORA metrics and tracing from Argo Workflows to check the workflow status, the queue depth, the latency, and all that fun stuff. So we are going to use workflow tracing and OTel CLI for the same. Coming to Argo Workflows, so whenever we go to the Argo Workflows UI and we start a new workflow, we always see a DAG. So a DAG is a directed acyclic graph of how the workflow is going to look like. But if you see that particular tab on the top right, we are going to also see a timeline view. And this timeline view is something very similar to what you see when you are looking for a trace. So this is a waterfall model of how your DAG is being executed at the moment. So there might be a DAG where A is the root step of the DAG and B and C are executing parallelly. And D is the final step of the DAG. So it gives us a lot of information of how this looks like. But if you want to get or capture more attributes out of it, we need something like workflow tracing for the same. So what are we trying to achieve here? We are trying to achieve three particular things. One, we are trying to achieve the tracing support for both ArgoCD and Argo Workflow using OpenTelemetry. The second thing is DORA metrics for your CI/CD pipelines. And the third one is we want to get deeper insights into how deployment and workflow pipelines are working. What is the error? Why is it erroring out if any step is taking longer? What is the latency? What is the problem? And if everything is functioning correctly. So let's talk about OpenTelemetry because it's going to be the backbone of whatever we are doing right now. So OpenTelemetry is a protocol, open standard, open source protocol, which helps us to unify observability and melt signals into one particular format. So melt is metrics, events, logs, and traces. And why are we using OpenTelemetry? So OpenTelemetry, if you don't know, is the second fastest growing project on CNCF, only after Kubernetes. So it's very popular and very high in demand. Apart from that, it does not have any vendor lock-ins. It gives us open source instrumentation. And it can be plugged in to any vendor who supports OpenTelemetry. So SigNoz supports OpenTelemetry. We are OpenTelemetry native. But there are other vendors as well which supports OpenTelemetry, so we can directly plug and play with anything. Apart from that, it provides SDKs for metrics, traces, and logs that we have mentioned earlier. But apart from that, profiling signal has just been recently introduced by OpenTelemetry in the latest release. So yeah, it was like this PPT was made like 3 days ago, so it is not mentioned here. But yeah, profiling instrumentation has also been released. So what is the general architecture of how OpenTelemetry instrumentation looks like? So there is an OpenTelemetry collector. So we can deploy the OpenTelemetry collector anywhere inside the microservice, outside the microservice, to any place you want. It can be communicated via either HTTP calls or gRPC calls. And there are multiple applications. So here we have app 1, app 2, and app n. And they send all their telemetry data to OpenTelemetry collector, which can then be stored to a trace store, a metric store, a log store, and all the signal stores that are supported by OpenTelemetry. What are we trying to do here? What architecture are we bringing? So the architecture that we are trying to showcase is an OpenTelemetry collector, which is there in between. We have a workflow controller, we have a workflow server, we have ArgoCDs. So workflow controller is going to send out traces. Workflow pod is going to send out traces and metrics, and ArgoCD is going to send out metrics directly to OpenTelemetry collector. OpenTelemetry collector is then going to send all these things to a trace store or a metric store, and it can be visualized on SigNoz right now. So metrics visualization on ArgoCD is a bit tricky, I would say. So it exposes a lot of things. It exposes application controller metrics, application set controller metrics, API server metrics, repo server metrics, commit server metrics. But we would be majorly interested into three things, which is which has been hosted on 8082, 8083, and 8084, which is the application controller metrics, the API server metrics, and the repo server metrics. Why do I say that metrics visualization is a bit tricky on ArgoCD? Because it doesn't directly give us OTLP format. We have to get a Prometheus collector to actually capture these metrics, scrape these metrics from a particular endpoint, and then send it to the OTel collector. For Argo Workflows, it is pretty straightforward. For metrics visualization, it sends all the metrics in OTLP format. Apart from that, in traces visualization, the problem with traces visualization is that it does not send traces via an OpenTelemetry agent. We have to use something like an OTel CLI. So what is OTel CLI? OTel CLI directly executes your commands or OTel formatted SDKs into your bash, such that all the traces can be sent to OpenTelemetry collector and then to a particular trace store. So here we can see that we have a workflow with 3 steps, which is fetch data, transform, and finalize. And it starts with something like a root span. So all the 3 spans will be coming out in one particular trace so that we can figure out what is going on. Right now, we see 0.00 ms because we do not, whenever I made that demo, it did not had anything in it. So it was pretty fast to just execute everything. Apart from that, prerequisites for instrumentation, we have, you should have ArgoCD and Argo Workflow installations. That's pretty straightforward. You should have Kubernetes. For ArgoCD, we should have a Prometheus scraper for metrics. We should have an OTel collector so that we can send all the OTel data to OTel collector. We should have OTel CLI for Argo Workflows in particular. And we should have pod level and cluster level access because OTel CLI is directly it is directly hitting the pod level of Argo Workflows. And we should have an observability backend. And in this case, we are going to use SigNoz. So there are 3 key OTel CLI commands, and I am going to show that later as well. But there is the start of the root span, where we say OTel CLI span TP print, and TP is trace parent. So trace parent is a command which actually stitches all the trace, all the spans of a particular DAG into one particular trace. Then there is a start of step span or the child span, where we are going to percolate the span, the trace ID from the root span to the child span. And we are going to ask them to stitch all this together. And then there is an export command, which will export it to an OTel collector. So right now in our demo, we are going to deploy one OTel collector on our Minikube or Kubernetes cluster itself. And that OTel collector will collect all these metrics and traces and then send it to the OTel collector of SigNoz. And we will see that in action as well. And for metrics instrumentation, we have to provide a Prometheus scraper with some scrape interval and slash metrics endpoint for scraping this. And we can see that we are we are just interested in the 3 ports that I have mentioned earlier. So which is 8082, 8083, and 8084. So let's start with our basic demo. Then we are going to talk about the CI powered demo as well. So in this basic demo, what we are going to do is we are going to put in an OTel collector. So we are going to deploy an OTel collector. So in this OTel collector, I have put in the SigNoz injection key. It will be active throughout today. So if you want to use it, you can. But after that, I will just disable it. So just go ahead if you want to copy it, I don't mind. Yeah, I could have passed that as an environment variable, but yeah, how much data can you actually send? So yeah, that is there. And then we are going to put in all the receivers. So there is the endpoint for gRPC, which is 4317, and for HTTP, which is 4318. For traces, I am going to use the endpoint of, so you have the traces endpoint as well. I gave you the ingestion key earlier. Please go ahead. Yeah, so we have OTel, HTTP, SigNoz traces, and we have the endpoint here. For metrics, the endpoint would be same, and it will be appended by /v1/metrics directly. And for tracing, it will be appended by /v1/traces automatically. So that's not a problem for us. We could have just reused here with a variable. And we are going to add in all the pipelines and the receivers and the processors and all this stuff. It is an OTel collector YAML, so we can add in a bunch more stuff, like if we wanted to do any sampling, if we wanted to like rate limit it, we can do that as well. So I also have some RBAC controls and all that stuff. But this is pretty straightforward, and it's a very simple OTel collector configuration. Apart from that, if I go to what the actual workflow is looking like, so we have a root span, then we are going to have a step A child span, we are going to have a step B child span. Yeah, so the dependency is step A, so only after step A execution is going, the step B execution is going to happen. And then we have a finalized step C emit child span, which has a dependency on step B. After which we are also using the OTel CLI command here, so that it exports those traces and metrics to our collector. And then it's pretty straightforward of how this is going to happen and where we are going to get the OTel CLI from. So from this GitHub, you can directly get the OTel CLI command as well. Let me show you what is happening here. So if I check the Kubernetes context, I have Minikube, so I will go here. Okay. Yeah, so I hope that it's visible. Yeah. So in our observability namespace, we have the OTel collector running. Okay. So in this OTel collector, we can see all the logs and everything. All the metrics and all the logs can be printed out in the OTel collector as well, if we say the verbosity to be very detailed. It can also, I can just showcase nothing if we disable the verbosity of OTel collector. Coming back to our Argo namespace, so we have an Argo namespace, we have Argo server running, and we have a workflow controller running, and all the necessary stuff for Argo workflow. Let's just port it forward. So I am going to port forward it to, okay, just give me a minute. Yeah. So if I go to localhost 2746, I get the Argo workflow UI. And also I have a bunch of, because I was making the demo, I made a bunch of workflows, so I can go to any workflow and show you the timeline view as well. So the timeline view looks something like this in Argo workflows. So this is the waterfall model that I was talking to you about earlier. Now, if we get to the fun stuff, we see that we just have to, just give me a minute. Oh, not this one. Yeah, so earlier we had a couple of workflows here. So in this workflow, I am also exposing the metrics of these particular child spans and the root span. I am just going to apply this, like create a new workflow this. I have created a new workflow. If I go into our Argo Workflows dashboard, I see that it has errored out. Wow. So I am going to use another workflow for it. That is not a problem. So yeah, so if I use another workflow and check, so a new workflow has been created, and this is just getting created right now, but it will also expose a root span. So now the root has started working, and it has gone to its child span, which has a dependency on the root span, which is the step A. It goes to step B and all that stuff. If I go to our SigNoz dashboard, yeah. So yeah, so previously you sent all the data on the ingestion key that I had mentioned earlier. I also mentioned the ingestion URL, but if you want to check where all your data is going, you can just go to legalbluejay.us staging. So you will find all the data that you have ingested earlier. Now if I go to our traces, and for the last 5 minutes, I see that a new workflow trace has been created. So if I click on this, we have all the whole workflow as a waterfall model, as a flame graph. Now the flame graph is not here. It is not because it does not exist. It is like this because it is coming in instantaneously. So all the steps are at one single point, which is 0.00 ms. I should have delayed it by a second or something so that it would have been visible. But yeah, so in this part it should have been a flame graph. But we are more interested about how the waterfall model is going to look like and what all information about the attributes we are getting. So let's just say if we want to check the step A, we are getting what is the namespace and what all service name is getting in, what else the attributes of that particular span. So this is how a trace would look like. If we have multiple parts in a DAG, then it would be slightly different, but all will come from one particular service name, which would be an Argo workflow, starting with the workflow name or the ID, and then all the child span as the child of this particular service. Apart from that, we went to this part. We also checked that the whole trace has been completed. Just give me a minute. So the whole tag has been completed. I can go back to SigNoz. I can go to metrics visualization, and I can see whether we have our metrics as or not. So so there is how many workers are busy right now. So I can just check that. And none of the workers are busy right now. I can go into our our Minikube cluster as well and see that nothing is getting run right now. So no workers are busy. Apart from that, we are if you go to the workflow, I will have to check what tab is in it. So yeah, you can go to Argo Workflows documentation and check what all metrics are being exposed right now. But one of them is workers busy count. We can also check the workflow condition if it is running perfect or not. So if I do that, yeah, so it is at a good condition right now. If I see the queue depth as well, I can get the queue depth as well. So the queue, there is no queue right now because no workflow is in progress and no workflow is there running or in queue. So it is 0. But if I start a new workflow, it will probably start with something else. So apart from that, I can also check the latency. So there is a queue latency bucket, and I can check that. So there was some latency of about 0.9 seconds. In which the workflow got completed. After that, there was no metrics exposed. So that was all about this. But we also talked about CI. So Shivai is here from GitLab, who is going to help us taking us through the CI part of this. So because the CI part was demoed on his laptop, he has sent me a recording, and he can just take us through it. So yeah. Yeah, can you take us through it?
Yeah, so as we are saying that we also want to be able to observe how, if you're running a CI pipeline, and basically if anyone wants to later take an example of how we build this entire CI. By the way, like fun fact, we built this completely with the help of AI as well, in order to help us assist in making this demo in just 1 hour. But the idea here is that we wanted to also expose metrics that can come from your CI pipelines that are running. And essentially, this particular file that you're looking at is basically the .gitlab CI. So if I quickly go back here, you can see that I'm just quickly showing you. And we are doing a very similar kind of example where we had like one trace and then we have multiple child from that particular span. And we are trying to now demonstrate and connect it with SigNoz and with the help of OpenTelemetry to be able to check out logs that we can get from the collector, right? So idea would be that you start to execute this particular CI pipeline. So if you're pushing some code and your CI pipeline starts to run, and then over here, you can see that this was one example where this particular entire pipeline ran successfully. And this is the final integration test where you can see that we have created our spans and all the child spans, and all of those logs are pretty much like coming from there, right? And the idea is, again, to be able to expose your CI, because sometimes you might want to look at metrics coming from your CI, right? Sometimes if your CI pipelines are failing or maybe they're not performant enough, you want to get those metrics. So that's the primary idea of being able to introduce a CI pipeline as part of your entire OTel to be able to get those particular logs. So here you can see that our entire job was succeeded. And now we will move back to be able to also visualize this with the help of Argo Workflows and with SigNoz.
Yeah, so if I go back to our traces, it was done like 30 minutes or like 1 hour ago or something like that. We can see that this has been executed with the help of CI. And although in this particular, when the workflow is running, it does not populate what CI it has been generated from. But with the help of like certain attributes in OTel, we can populate that as well. And we can check what are the CI, what are all like CI is being used here. Coming back to the presentation, let's just talk about, let's just talk about the architecture that we took us through in our CI demo. So let's just say that I am a developer and I have integrated like our CI with Argo Workflows. So I am just going to make a workflow definition or a CI definition at GitLab, and we are going to like push a new workflow definition in GitLab. It will also send GitLab from its CI will send its data to our OTel collector, whereas the workflow that has been created on GitLab will go through Argo Workflows, then to Kubernetes, and then to our OTel collector. And from there, we can just visualize everything on whatever backend that you are using, and in this case, SigNoz. So that is a very simplified architecture of what we did right now. So wrapping up, we brought observability to our CI/CD pipelines. We also instrumented Argo Workflows using OTel CLI and OTel Semantic Conventions. We captured root plus step spans for full workflow traces. And we exported everything to SigNoz for trace visualization, troubleshooting, and metrics visualization. Recently, there has been a SIG in OpenTelemetry community, which are trying to standardize the semantic conventions for CI/CD and particularly ArgoCD. So you can visit the OpenTelemetry website for checking out these semantic conventions, and you can also join the SIG to probably contribute of how this is happening. Apart from that, you can also come to our solution showcase booth at 1372 to meet the SigNoz team. Every one of us would be in orange jacket. Look around you, there might be many. So yeah, so that was it. And thank you so much for coming to this presentation. Anyone has any doubts? Okay, so I'll just come down the stage. If you have any doubts or you want to talk to me, we can talk to you afterwards. Thank you so much.